Hello students, this is a video on the topic tests for quant available on the Bodhee Prep Android app. Now, the idea of these tests is once you've done the basic concepts of a topic, you want to check whether you're able to apply those concepts in the exam or not. That is when you take the test. With every test, there is a video which gives you the solutions and a brief analysis of what would have been a good attempt. There are more than 200 such topic tests available on the Bodhee Prep Android app. So make sure that you download the app from the link in the description below and make the most of these tests. This video is on probability, and this is the first test on probability that we're discussing as per the app. Overall, I think the level of difficulty was moderate to difficult level, and about 5 to 6 questions, net correct out of 10 will give you definitely a 95 plus percentile in this kind of a test. Also, the attempt time for this test would be about 20 to 23 minutes. In this time, I would want to get my 5 to 6 questions net correct, and that is it. I might not be able to solve all questions, and that will not be my target for this test either, when I'm giving it like an exam. Now, if you look at the questions, question 1 says, words with or without meaning are to be formed using all the letters of the word examination. Examination has EXA, examination. These are the alphabets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5. 3 repeats. The probability that the letter M appears at the fourth position. 1, 2, 3, 4. M is fixed here. 5, 6, 7, 8, 9, 10, 11. Now there are 10 alphabets that are to be arranged. This can be done in 10 factorial upon, because A repeats, divide by 2 factorial, I repeats, divide by 2 factorial, N repeats, divide by 2 factorial. These are the favorable cases. Total arrangements would be 11 alphabets are there, 11 factorial upon 2 factorial, 2 factorial, 2 factorial. And therefore, the probability will simply be the division of these. 2 to 2 cancel out. 10 factorial upon 11 factorial gives me 1 by 11, and that becomes my answer. Favorable number of cases upon total number of cases, option 2 becomes my answer. Again, this question I would say is probably easy to moderate, maybe a minute and a half to solve. The probability of selecting integers from the range -5 to 30 such that -5 and 30 both are included, square brackets, such that x square plus 2a plus 4 into x minus 5a plus 64 is greater than 0. This quadratic has to be greater than 0. If a quadratic is always greater than 0, that means it does not have real roots. Therefore, the discriminant has to be less than 0. The discriminant here is 2a plus 4 whole square b square minus 4, a is 1, 5a plus 64. This has to be less than 0. Divide the entire thing by 4, 2 square 4 and 4 cancel out. I am left with a plus 4 whole square minus minus plus 5a minus 64 less than 0. A square plus 16 plus 8a minus 5a, sorry, plus 5a minus 64 is less than 0. A square, this is plus 13a minus 48 is less than 0, which means a plus 16 into a minus 3 is less than 0. So critical points will be 3, a minus 3 is equal to 0, and minus 16, positive, negative, positive. So for discriminant 0, a can lie between minus 16 and 3. Our range was minus 5 to 30. So the favorable cases will be, value of a could be minus 5, lies in this range, minus 4, minus 3, minus 2, minus 1, 0, 1, 2. Here equal to is not there, so a cannot be 3. So 1, 2, 3, 4, 5, 6, 7, 8. 8 favorable cases. Total values for a is from minus 5 to 30. So minus 5 to minus 1, 5 negative, 1, 0, and then 30. 36 cases. Therefore, the probability would be favorable cases upon total number of cases divided by 4. 2 by 9, or option 2 becomes the answer. I will call it a moderate question because a quadratic has to be solved, and then overlapping cases have to be counted, maybe 2 to 2.5 minutes to solve. Let ABC be 3 events such that probability that exactly one of A or B occur, exactly one of A or B occur, is 1 minus k. Probability that exactly one of B or C occurs is 1 minus 2k. Probability that exactly one of C and A occur is 1 minus k. Probability of all ABC occurring is k square. Probability that at least one of ABC occurs. Probability of at least one of ABC occurs is nothing but P of A union B union C. This is P of A plus P of B plus P of C minus P A intersection B minus P B intersection C minus P C intersection A plus P A intersection B intersection C. We have to find out the value of the right hand side. Now, probability all three occur simultaneously. This is given as k square. Also, when we say probability that exactly one of A and B occurs, exactly one, can I not say from probability of A union B, if we subtract A intersection B, again, we will be left with exactly A or B occurring. Therefore, P A union B, or rather, this part is equal to 1 minus k. Similarly, P of A, sorry, P of B plus P of C minus 2 times P of B intersection C is 1 minus 2k. P of C plus P of A, exactly 1 of C, minus 2 times P C intersection A is equal to 1 minus k. If we add these three, we will get 2 times of P of A plus P of B plus P of C minus 2 minus P A intersection B minus P B intersection C minus P C intersection A will be the sum of the numbers here. This will be 3 minus 3 minus 4k. And therefore, if you look at this here becomes 3 minus 4k by 2, the first six terms plus k square. This can be written as 2k square minus 4k, 2k square minus 4k plus 3 by 2, which is nothing but solving this further. I'll write it here. 2 into k square minus 2k plus 1 plus 1 upon 2, which is 2 into k plus minus 1 whole square plus 1 upon 2, or k minus 1 whole square plus 1 by 2. Now, probability of A union B union C is this term. K minus 1 square will be a value which is greater than or equal to 0. Therefore, this sum will always be greater than or equal to 1 by 2. Hence, the probability that at least one of ABC occurs will be exactly greater than 1 by 2. In that sense, because K is not 1, this will never be 0. Therefore, always greater than 2. Option B becomes my answer. Again, this question I would say is a difficult question. Definitely not something that you would come across very regularly. And the solving time also will easily be 2.5 to 3 minutes. 4 dice are thrown simultaneously. Numbers shown on these dice are recorded in a 2 by 2 matrix. 2 by 2 matrix. The probability that such formed matrices have all different entries and are non-singular. Non-singular matrices are which have value non-zero. That is, if I say ABCD, if AD minus BC is 0, this will be called a non-singular matrix. Now, total ways of filling this will be dice numbers are filled as 6 into 6 into 6 into 6. Total possibilities is 6 into 6 into 6 into 6. In terms of favorable cases, all entries have to be different. So if there are 6 options here, 5 here, 4 here, 3 here, which is 6 into 5 into 4 into 3, 30 and 360. From this, we will remove the options where we get a singular matrix. Now, for singular matrix, the possibilities are we could have 1, 2, 3, 6, where 2 into 3 is 6, 1 into 6 is 6, or we could have 12. 2, 3, 4, 2, 3, 4, 6, 3 fours are 12, 6 twos are 12. These are the two cases possible where we'll have a singular matrix. How many cases will be possible? Suppose from here I put in the numbers. If I put 1 here, 6 has to be here. AD. 2 and 3 can interchange. So two possibilities. And this number could be any one of 1, 2, 3 or 6. So overall 4. So 8 cases will be possible here where we'll get a singular matrix. 8 cases will be possible here. The total number of cases here becomes 16. Out of 360, we will subtract these 16 numbers, or 360 were the cases that we were forming with different numbers. For these 16 cases, singular matrix we get. So we are left with 334, 344, 344, 8, 9, 10, 11. 344 favorable cases upon 6 into 6 into 6 into 6. Total number of cases. So if we divide by 344 divided by 4, will be 86. 86 divide by 4, 3 and 3 are left. 43. Who is left? And therefore the overall answer will come out to 43 by 162. Option 4. Again, in terms of level of difficulty, definitely not an easy question. Moderate to difficult. Also, there are multiple things that are being multiple concepts that are being checked. Non-singularity of a matrix number being filled, and therefore I think the solving time might not be high, but conceptually it is a moderate to difficult question. 9 distinct balls be distributed among 4 boxes. 4 boxes. So in how many ways can this be done? 1, 2, 3, 4, 5, 6, 7, 8, 9 balls are there, distinct. No, total number of cases will be each ball will have 4 options for boxes. And therefore total of 4 raised to power 9 distributions are possible. Probability that B3 contains exactly 3 balls. If B3 has exactly 3 balls, what we'll do is we'll choose 3 out of the 9 balls. Then the 6 balls are remaining. We'll put them in B3. 6 balls are remaining. 1, 2, 1, 2, 3, 4, 5, 6. For each of them, now there will be 3 cases. They could go into B1, B2 or B4. So the total number of distributions such that B3 contains exactly 3 balls will be 9C3 into 3 raised to power 1, 2, 3, 6. It is given that this is equal to K into 3 by 4 raised to power 9. The probability in this case will be 9C3 into 3 raised to power 6 upon 4 raised to power 9. Obviously 4 raised to power 4 raised to power 9 cancel. So K into 3 raised to power 9 becomes 987 upon 321 into 3 raised to power 6. 3 raised to power 6, 3 raised to power 3 cancel. So from here we can say this 3 and 3 square, 9 will be left. 9K is equal to 28 or K is equal to 28 by 9. This is 3 point something. 3.111 to be precise. K lies in which of the range? If you look at this, mod of x minus 3 is less than 1, which means minus 1 is less than x minus 3 is less than 1. Add 3, 2 is less than x is less than 4. We see that 3.11 lies in this range and therefore option 1 becomes my answer. Again, moderate level of difficulty. Calculation is a little tricky in this case, and we'll have to check with options. So about 2.5 to 3 minutes to attempt. Let x be a random variable such that probability function of a distribution is given by px0 is 1 by 2. Px is equal to j is 1 by 3 raised to power j, where j is 1, 2, 3, and so on up to infinity. Then the mean of the distribution is to be calculated, and px is positive and even. This is to be calculated. Now for mean, we say mean is nothing but sigma xi pi, variable into probability. When variable is 0, probability is 1 by 2. When variable is 1, probability will be 1 by 1 into 1 by 3 raised to power 1. When variable x is 2, px is equal to 2, variable probability will be 1 by 3 raised to power 2, 3 into 1 by 3 raised to power 3, and so on. This is the mean that we are calculating. And then 1 by 3 plus 2 by 3 square plus 3 by 3 cube, and so on. This is an AGP. So we multiply m by 3 again, 1 by 3. This will become 1 by 3 square plus 2 by 3 cube, and so on. Take the difference of these two. So 2m by 3 is equal to 1 by 3 plus 1 by 3 square plus 1 by 3 cube. This is a infinite geometric progression. So 2m by 3 will be equal to a upon 1 minus r. 1 by 3 upon 2 by 3 is 1 by 2, and therefore m will come out to 3 by 4. Hence mean is 3 by 4. Then we look at the value of p is x. P of x is positive and even. X being positive and even means x would be 2, 4, 6, and so on. The probability of this is 2, 4, 6, 8. X positive and even will be P of 2 will be 1 by 3 raised to power 2. P of 4 will be 1 by 3 raised to power 4, 1 by 3 raised to power 6, and so on. Infinite GP is formed. The sum of this GP will be A upon 1 minus R. So 1 by 9 upon 8 by 9, which will come out to 1 by 8. This probability is 1 by 8, and therefore option 2 becomes the answer. For me, I will call it a difficult question because both these concepts are maybe higher math related concepts, and therefore not something that you would come across very normally. Solving time about 2.5 to 3 minutes. A fair coin is tossed n times such that the probability of getting at least one head is 0.9. Then the minimum value of n is probability of getting at least one head. At least one is 0.9. So can I not say probability of getting 0 heads is 1 minus 0.9, that is 0.1. Now if n tries happen and probability of getting 0 heads we are calculating for an unbiased coin, when n is equal to 1, probability will be 1 by 2. When n is equal to 2, probability will be 1 by 2 square, tails and tails. N is equal to 3, probability of 0 heads will be 1 by 2 cube, tails, tails, tails. This is 0.5, this is 0.25, this is 0.625, 0.125, sorry. When n is equal to 4, probability of getting 0 heads will be 1 by 2 raised to power 4. 1 by 2 heads, 1 by 2 heads, 1 by 2 heads, 1 by 2 heads, which will give us 0.0625. So when n is equal to 4, when n is equal to 4, probability of getting 0 heads is 0.0625, which is less than 1, and therefore probability of getting at least one heads will be greater than 1 minus 0.1, which is greater than 0.9. So we have to do this process 4 times, and we can be 0.9% sure that there will be at least one head. I think hit and trial method works here. Moderate level of difficulty, about 2 minutes to solve. The probability that a randomly selected 2-digit number belonging to the set n, where the number is 2 raised to power n minus 2, is a multiple of 3 is equal to. Now n can be any number from 10 to 99. Total cases becomes 90. What is favorable? Favorable is when 2 raised to power n minus 2 is divisible by 3. Now suppose n is even. If n is even, 2 raised to power n minus 2 can be written as 3 minus 1 raised to power n minus 2 divided by 3. If n is even, the remainder from here will be 1. Here minus 2, overall remainder will be minus 1, so not divisible. If n is odd, 2 raised to power n minus 2 by 3. If we check, this becomes 3 minus 1 raised to power n minus 2 by 3. Minus 1 raised to power odd will be minus 1, so remainder will be minus 1 minus 2. Minus 1 from here, minus 2 from here, which is minus 3 overall. So this will be divisible. So whenever n is odd, we will have a number divisible by 3. Those are the favorable cases. From 10 to 99, half of the numbers are even, half are odd. So 45 even numbers and the odd numbers, and therefore probability will be 45 out of 90. All odd numbers are favorable cases. All the numbers are total cases, and therefore the probability is simply 1 by 2, option 3. Concept of remainder is involved, therefore uh, uh, that is something that you have to be comfortable with. Otherwise, it's a simple question. We are just looking at divisibility by 3. Even if we take the value of n as 10, 11, 12, might be able to get the answer from there as well. A student appeared in an examination consisting of 8 true or false questions. The student guesses the answer with equal probability. Therefore, half probability 1 by 2, the answer will be right, half it will be wrong. The smallest value of n, so that the probability of guessing at least n correct. At least n correct question means either n or n plus 1 or n plus 2 or n plus 3 up to 8. Number of questions that the student can get correct is 0, 1, 2, 3, and so on till 8. So we have to find out at least n correct. Now, probability of getting exactly n questions correct would be 8cn binomial event into 1 by 2 raised to power 8, because the probability of success and failure is same. So we'll get this. Probability of getting n plus 1 questions correct would be 8cn plus 1, 1 by 2 raised to power 8, and so on. 8cn plus 2, finally 8c8, 1 by 2 raised to power 8. This probability has to be less than 1 by 2. Multiplying throughout by 2 raised to power 8, we'll get 8cn plus 8cn plus 1, and so on till 8c8 is less than 2 raised to power 7, 2 raised to power 8 by 2. Now we know that 8c0 plus 8c1 up till 8c8, this is nothing but 2 raised to power 8. Therefore, 2 raised to power 8 minus 8cn, 8cn plus 1 up till 8c8. So we're taking terms from here and subtracting from here, will give us, or rather, better approach will be, we write this as 8cn, 8cn plus 1 up till 8c8 will be nothing but 2 raised to power 8 minus the first few terms come on the right hand side. So 8c0, 8c1 up till 8cn minus 1. So here I am replacing this and writing the new expression. 2 raised to power 8 minus 8c0 plus 8c1 plus 8c2 up till 8cn minus 1 is less than 2 raised to power 7. This is 2, 4, 8, 16, 32, 64, 256. This is 128. This comes here again. 256 minus 128. This comes here, so we'll get, on rearranging the terms, 8c0 plus 8c1 up till 8cn minus 1 being greater than 2 raised to power 7. 8c0 is 1, 8c8 is 8, 8c2 8 into 7 by 2 is 28. 8C3. 8 into 7 into 6 by 3 to 1 is 56. This is not crossed 128 till now. The moment we find 8C4, 8765 upon 4321. 6 cancel, 4 to 7, 70. This is where it will cross 2 raised to power 7. And therefore 80, 81, 80, 83, 84. So n minus 1 has to be greater than equal to 4, which means n has to be greater than equal to 5. The minimum value of n is 5 becomes the answer. Definitely a difficult question. Multiple concepts involved. And attempt time easily 2.5 to 3 minutes. Let A and B be independent events such that P, probability of A is P, probability of B is 2P. The largest value of P for which P, exactly one of A or B occurs. If exactly one of A or B occurs, this will be P of A occurring into B not occurring plus A not occurring into B occurring. This will be the probability of exactly one of A B occurs. This is given by 5 by 9. Since probability of A happening is P and B is 1 by 2P, no, P not happening will be 1 minus 2P. P not happening will be 1 minus P. B happening, A not happening will be 1 minus P. B happening is 2P. This is 5 by 9. P minus 2P square plus 2P minus 2P square. 2P square to 2 is equal to 5 by 9. This becomes 3P minus 4P square is equal to 5 by 9. 27P minus 36P square is equal to 5. 36P square minus 27 plus 5 is equal to 0. So we're looking for two numbers which have a product of 36 and 5 and a difference of 27. 12 and 15. So we write this as 36P square minus 12P minus 15P plus 5 is equal to 0. So taking out 12P common, P minus 3, 3P minus 1, 3P minus 1 minus 5 into 3P minus 1 is equal to 0, which means 12P minus 5 into 3P minus 1 is equal to 0, which means either this is 0, which gives us P is equal to 5 by 12, or this is 0, which gives us P is equal to 1 by 3. Largest value of P, 1 by 3 is nothing but 4 by 12. Therefore, the larger value is 5 by 12, so P becomes 5 by 12, option 4. Again, this I think is a moderate level of difficulty, not more than 2 minutes to solve. So if you look at the overall paper, moderate to difficult level paper, 5 to 6 questions we are looking at in about 23 minutes. For me, these questions would be 1, 2, 5, 7, 8, 10. Which are these? Definitely doing a standard question. This one also, I think, was just solving the quadratics or doing this as well. This, I think, was a different question, so not counting this question. This one also, I think, talked about non-singular matrix, not counting this question. This, I think, was a standard question, should have been attempted. Again, mean and extra, not counting this question. This should have been attempted, just multiplying 1 by 2 till we get a value less than 0.1. This again could have been attempted. 2n minus 2 divided by 3 is all we were checking for. This question, I think, is a difficult question, not counting this as an attempt question. This I would have done because standard process is involved. So out of 1, 2, 5, 7, 8, 10, I'll try to find my 5 to 6 questions and get a decent percentile or required percentile.